Hello there, it's Jay here from Jay's Vintage Junk, and today we're back on with the Hitachi S-4000 project. And I don't know if you can see quite straight away, but we've got some holes there. What I've done basically, all the electronics are now stripped out of this console, and I've actually started converting this now into, like I said, a desk kind of. Either a computer desk or a workstation. I'm not 100% sure exactly how I'm going with it yet, but I'll show you what I've done so far just quickly before we actually start what this video is really going to be about. So as you can see, it looks pretty much as it did before. If I just tilt you down on the camera, you look underneath, I've actually cut out now all the inside here. This can still come out, that just pulls out on its runners, but that's the next thing that's going to be changed. The next thing I'll be doing is getting rid of the keyboard there, and I'll be changing the way the runners work. I'll be removing the original runners that this keyboard runs on, and I've got some old drawer runners, some really nice high quality drawer runners, and I'll be mounting one right at this side here and one right over on this side over here. And basically building a new work table, which will basically just come out about that far, but it'll be on the drawer runners, and it'll be able to slide out to a full length like that, and then just slide back in, so I can put a keyboard or whatever I'm working on, and then just slide it away when I'm not using it. Obviously I've cut out what was there now. That'll be right up to the top there, so I've got plenty of room in there for, you know, like my main PC, a couple of other computers and things like that, and basically that's kind of what I'm planning to do with this thing, just turn it into a PC console, but with a difference. What I'm probably going to do here, just get you up again, I'll probably be removing all this lot in there and putting a nice LCD panel in there, a nice VGA or what have you, but basically a modern LCD panel for use with computers. But then I'm hoping to get the two monitors that were originally in there actually working again and actually functional again. And we'll just have a breakout panel somewhere, possibly down here or something, so we can actually access and actually use those monitors for, you know, testing old consoles or old computers and things like that in the future. And what I thought we'd do in this video is we're going to have a... Let me get back on shot so you can see me. What I thought we'd do in this video basically is have a look at the two monitors that I've actually pulled out of there. I've got them over there on the workbench. So what I'll do is I'll set the camera back up actually on those monitors, and we can have a proper good look over them. One I think is going to be... One's interesting, one's actually colour, which I wasn't expecting. But there's a few issues with actually getting that one fired up and actually perhaps getting something into it. The other one might be quite easy, so what I think we'll do, we'll have a look at them both in this video, but one of them we might actually have a look, seeing if we can get it to fire up and actually see if we can perhaps get a signal up it and see if it actually works alright. It does appear to have some screen burn, and until I can actually get it fired up and see how bright it is. I mean, the CRTs could be absolutely knackered in these, and them basically not be worth doing anything with, but until we can get them actually running and get them displaying something, we won't really know that. So I'll pause the video, just get us set up on the bench, and we can have a quick look at these two monitors. So back in a sec. Right, okay, here we go. Basically what we've got a mono or a black and white. I don't know what the phosphor colour of it is, but we've got a mono CRT here, and we've got a colour CRT here. Which one shall we start with? Let's start with the colour one, because that's probably the more interesting of the two. So we'll slide the black and white one off to, well, I want to say black and white, I mean mono, because until we can get it fired up, I don't actually know what colour that phosphor is. So it could be black and white, it could be green screen, it could be amber screen. I don't think it's amber, it's either green or black and white, to be honest. Because I have seen these fired up. Like I said, when I first saw the listing for this computer on eBay, the screens were fired up. One was just showing, wasn't really showing anything, it was just kind of showing a slightly distorted raster. The other one was just had some text on it in green. So I'm presuming that's probably it's probably a green screen. Or I said this is a colour set. This is a colour monitor. And basically what we've got here, these are industrial monitors. This is how they come. They don't have a cabinet or anything. They're just basically a chassis like this. And these would be used for all kinds of things. These weren't specifically designed for use in scanning electron microscopes or anything like that. These were designed for industrial control applications. So CNC machines, you know, big computer-controlled lathes, that type of stuff would use monitors like this. X-ray machines, you know, chip and pin machines, the old 1980s original chip and pin, you know, hole in the wall kind of machines. They would use screens like this, industrial monitors. And the build quality on it is absolutely amazing. That thing there, that massive big thing there, that's the line output transformer. If you are familiar with repairing, you know, CRT era televisions, and you're familiar with what a line output transformer is, and it's usually just got a bit of potting around it, you can see the coils and everything. This is either oil filled or it's entirely potted in resin. But we've got a massive line output transformer there. We've got, I presume that's focusing that unit there, but I think we've got a tripler here. So that will take the high voltage from there, stack it up even higher, and rectify it to DC to actually drive the CRT there. It is just really, really high. You know, in fact, what? So what is that? Alright, now I'm confused. Now I'm really, I'm really confused. No, sorry, ignore what I've just said. That there is the line output transformer. It is a fairly standard style line output transformer. That thing's the mains transformer. Wow. Yeah, that's actually the power transformer. So it has actually got a resin block power transformer. That's actually really interesting. That means this thing might be better than I was thinking. Oh, that's really good actually. Right, the problem with this is, as it was designed from the factory, this was designed to run on either 100 volts AC or 115 volts AC, 120 volts AC. It was never ever designed to run on 240 volts AC. Obviously 100 volts AC is the line voltage in Japan. 120 volts AC is the line voltage in the US and I think quite a few other countries. I think 100 volts is just Japan. Japan's weird like that. And obviously this was Japanese equipment really designed in Japan. And throughout the whole thing, as we've been tearing it down, we've seen that really the whole unit was designed to run on 100 volts AC as its line voltage. So initially I thought that was the line output transformer because of its proximity to that there. That is still a tripler or a doubler, but we've got a line output transformer up there which goes into a focusing unit there, comes out of that into, like I say, it's either a doubler or a tripler, out of that to actually feed the anode of the CRT. That there is actually a mains transformer to produce a low voltage AC to actually drive the rest of the monitor. Now that's really good, because providing we can figure out what AC voltage that thing gives out, and it's probably either 12 or 24 volts, something around that kind of voltage AC. It's labelled on the top, but it doesn't actually give an output voltage from it, unfortunately. It just says power transformer and a part number. I can't actually see anywhere on that it actually gives its output voltage. But what we can do, we can pull that transformer out, we can connect it up to a variac, give it 100 volts AC on its input, measure what its output, AC output is at the 100 volts AC input, And that voltage, that's our magic number. We can then find another transformer which has got a 240 volt primary tapping, but gives the same secondary output voltage as that transformer. And essentially that should allow us to run this monitor off UK mains without any problem at all. Like I say, it doesn't use a switch mode power supply or anything like that that's built onto the main board. It's quite old school, it's very heavy duty, very, you know, very well made, and it does look like I can actually modify it like that and actually fit a 240 volt mains transformer and get it running like that. The other option would be to simply fit a 240 to 120 volt step down transformer and drive it like that. But I'm not 100% sure of the current consumption. We can find that out when we variate this thing up and see whether that's an option as well. But it might just be simply just to take that transformer out and replace that with one that's more suitable for use in the UK. Because providing the CRT on this thing's okay, this could be quite a nice monitor, especially for building back into that thing. This thing's colour. I wasn't expecting to find a colour monitor actually in here. At the moment, all I've got is it breaks out to this cable here, and what I think we've got, by the look of it, it will have red, green, blue. So we've got RGB. Now we've either got a composite and a composite sync, or we've got RGB and we've got a separate horizontal and vertical sync. We've got two other wires there which I'm not 100% sure what they are, but I mean, could this thing be CJ, EJ compatible even? I'm not sure. Unfortunately, and I have looked, I cannot find any data on this monitor whatsoever. Turn it round. This is all I can find on it. It's an NEC, and the model number, I presume this is the model number. It's a DU-121BN000. There's a serial number underneath, and then we've got a date code which is a 10th. So it's, I don't know, that's the 10th week of the 10th month, 1988. Everything else is in Japanese character set. I suppose actually I could get one of them apps on my phone to try and decipher that, but I don't even have one of them things on my phone. But yeah, so it's a DU-121BN000. If I can find some data on it, I can actually find out, you know, what signal it's actually expecting. It's, you know, it does look like it will be a very nice monitor. We've got vertical size, vertical line, vertical hold, vertical position, horizontal hold. It does seem to just have like a brightness or a contrast control, as does the other monitor, and those are completely seized up. It's the same on the other monitor actually. Incredibly high quality potentiometers, but both of them are actually seized solid. You can't turn them at all. So what are they? I mean, they're 100k ohm. They'd be easy enough to replace, but I will try a little bit of WD or some service or something down there, see if I can get them to free up. But yeah, that's basically the colour monitor. I need to do some more research on it to actually try and find out what signals it needs. One thing though I have found which is a slight concern, just get this, that's the control there, and we've got our input there. Oh, I'll mention this as well. That was also connected to this. Now this, where's that? That basically, this is that board I mentioned in the previous video that was underneath where the monitors were on the system. I think, is it that one or is it that one? Yeah, this fits, oh, there it is. That plugs in there like that. And this says it's a video preamp. So we have some kind of video preamp board here. It's obviously quite simple, it's just based on transistors. Now I don't know why it needs this. Was it, like I said, I'm not sure why this monitor would need to be amplified from whatever signals were coming out, but we may need this, we may not need that, but we do have it. We can play about with it. I mean, it could even be that those two wires we've got there are those designed to take voltage from this monitor to drive this board. I mean, is this like an add-on board that could be supplied with this monitor? I don't know. This whole thing has a lot more questions before we can really look at getting into it and get it fired up and actually see if it's going to be any use to us. I'm quite looking forward to fiddling about with that, but I need to find some more data. I really could do with finding a data manual for this monitor to actually find out what frequencies it's designed to run on, what the sync signals are, things like that. So one thing that's very slight concern, it's not a huge concern, and they've both got them on them, these. It's actually got a fault tag. We've got LGC monitor, and it says AND booth, so I presume that's where it was actually being used at some point. Fault, horizontal oscillator slow, and that was from the 7th of the 7th, 2011. So it looks like this scanning electron microscope and the computer and everything was actually still in operation in 2011. And if you consider that, you know, it was built in the 1980s, that's not a bad service life, really, if you think about it. You know, this thing was actually being used for obviously, you know, a proper purpose from what we reckon this thing was probably late 1980s, say about 87, you know, somewhere around that kind of time. I think that's when these were current, and it was obviously, you know, with that ticket there, it was still being used somewhere, 7th of the 7th, 2011. Anyway, I'm going to put the colour onto this to one side for a bit. Because I need to find some more, do some more research before we can really do anything meaningful with that. I mean, yeah, we could connect it up to a variac and we could fire it up and see that see a raster on the screen. But that's as far as we'd be able to go with it. We wouldn't be able to really get it to display anything. And I want to look at seeing what I can do about actually making that run properly off the mains. Well, like I say, if we use a step-down transformer or replace the transformer in it. I wasn't expecting to be able to do that. I'm quite actually pleased with that. Right, let's get on to this one. It's little baby brother. Right, let's see if I can get you down so you can see that a bit better. Right, and this is basically so much simpler. This is very similar kind of thing. I was trying to find some service data on this, and I can't find any. I can't find a manual for it. But all I can find is reference after reference of monitors that LCD monitors that which were designed as drop-in replacements for these, and again these were primarily designed for use in things like CNC machines and control applications in industrial machines, stuff like that. And it is basically just as far as I can work out and I can gather, it is just a little composite input mono monitor. Very, very, very simple. I mean, really, really simple. We've got the same, we've just got a brightness or a contrast control, and again actually that one does turn, but it's very, very stiff. Actually, it's freed off, that one now. Yeah, that one's actually started to free off, the other one's absolutely seized solid. But that's either brightness or contrast. We've got BNC composite input, and the nice thing with this one, if I can find the wire, there it is. Unlike the other one, this one runs off 12 volts DC. So if we give it 12 volts DC on those two wires there, that should run it. That should actually allow this thing to power up, which, I mean, you know, that obviously makes it so we can actually fire it up and test it today and see whether it works well enough So we don't know what state the CRT is in it. I do think this does actually work, but I just don't know to what extent it works. It may need some remedial work to make it into a useful, usable little monitor. But this was made by Matus. I'm not going to be able to pronounce this, am I now? Matuchita, I think it is, Matuchisa, or whatever they're called. Anyway, they made it. And the model is, it's a TR120B1A. And again, like I say, it is just a really basic composite monitor. And hopefully, if this works, this should be quite a nice little monitor to go back in there for just a nice basic mono composite input. Other nice thing is that the entire harness is just on an edge connector there. We can easily just disconnect it, make a new cable up if we want. Unfortunately it's not keyed, so you do have to be careful which way around you plug it in, and it does plug in, if I remember correctly, that way around like that. Unfortunately, I've just noticed that the wire there has actually broken off its connector. It should be soldered on. It should be soldered on there like that, and it's actually, unfortunately, it's broken free. So what I'm going to have to do, I'm just going to have to get the soldering iron out, make a little repair there. Might actually put a different cable on it, something that makes it a little bit easier for us to test with a phono on it rather than that really thick, heavy-duty BNC. So what I'll do, I'll just pause you while I get the soldering iron sorted out and some cable and what have you, and we'll get back and we'll just do a little bit of a repair there, sort out a better cable for connecting it up, and we'll actually give this a test and see what we can get it to do. So back in a sec. Right, we're back and the soldering iron's all nicely warmed up now. In fact, what I think I'll do, I'll just disconnect that from there so we can work on it a bit easier. And that's what we can see. Basically we've got a ground connection there, and we've got the wire that's broken off there, so that's what we're going to get rid of. Pull that up there. I'm going to desolder that. Let me see if I can get you down a bit so you can see what we're doing. There we go. That's better. So what we'll do, we'll just sneak that off there, just heat it up and we should be able to just pull that out. There we go. And that can go in my wire bin. That will come in handy for something else. So we've got basically, we'll just get that bit of the inner conductor off there. These are all gold plated connectors as well, and all these wires have been bent over. You've got a mechanical joint as well as a soldered joint, so these were built by proper engineers. There we go, that's out. Tidy that up a little bit. You know, got really good practice on everything in this. Right, I'll just hold that down for a minute while I prepare the wire I'm going to solder onto there. Now this is only going to be temporary. Obviously we'll have something better than this, but for testing and for seeing what this thing actually does, this will do. This wire is a bit on the thin side, but I said just for messing about with, just to test it, this will work. Got a piece of wire here. Just get that tinned up. Just hold it with my my reel of solder. Tin the wires up. There we go. Turn that round because I knew it flipped over. I'll just want to solder. Like I said, this is only temporary while we play about with it, see if we can get a signal up it. But once we're happy with it, we can do something better than this when it actually goes back into the console. There we go. That'll do. That's good enough. And again, that one just needs to go over there to that end there. Just want to make sure it doesn't short on anything. It doesn't. It shouldn't do. Why I'm trying to just flip that off when I've got a set of side cutters here, but just snip that off there. There we go. So it's not the best of connections that, but it'll do for testing. We've got a ground there, and we've got a composite connected on there. Plug that back in, and that. Let me get you zoom back out so you can see what's going on. There we go. So basically we've just got a phono now connected on the back there where that old BNC was. That'll just make it a little bit easier to connect something up to this. Let's get it spun round so we can see it. Now, obviously we can't connect something up to them. That's our ground, that's our plus 12 volts. What I'll do is I'm going to tie a knot in the one that's going to be 12 volts. Like, well, a bit further down the wire. Because my big variable power supply, unfortunately, is still up in the attic. The little one I've got down here is only good for about 500 milliamps. It's a good variable power supply, but said unfortunately it's only good for about 500 milliamps. And looking at the little tag on the side of this wants 1.3 amps. To get it to fire up. What we do have though, and what we fired the S-4000 computer up with originally, is an old switch mode power supply, and this is good for about 15 amps on its 12 volt line. So this is absolutely fine, just as a quick test for getting this monitor up and running. So we'll strip them wires off so we can lash a connection up to that old switch mode power supply. This is lovely wire as well, really thick. And I've got loads of this salvage for projects. Alright, so that's good. We know that the one with the knot in there is our plus, we know the other one's the ground. And I can get the soldering iron out of the way a minute. We don't need that now because we've soldered. Put them away. And get the power supply in position. I'll just put that, it's just basically just off shot there. And I will lash up to the 12 volts. Push that in there. I'm basically just pushing the ends of the wires into one of the spare Molex connectors on the on that old switch mode power supply, just as a lash up test. This will do fine as, like I said, this will do fine as a quick lash up test to see if the monitor is actually going to do anything. So I'm fairly confident this is going to work, this monitor. But what we don't know is how good the CRT is, what the emissions left on that CRT. It is obviously, you know, from the 1980s, and it has been in use for quite a long time by the look of it. I think the colour one may be a replacement. 1988 seems a bit new for the age of the actual microscope, but This one, I can't find a date on it, so we don't really know. Right, that's connected up like that. I need an IEC lead so I can plug in that other that power supply and switch on. I've got the power supply bypassed on there, so it'll just power up as soon as I switch it on. And we'll see if we get anything to happen on the actual screen, and then we'll see about perhaps connecting something up to it. Right. I'll unplug my soldering iron. I'll plug this in there. Plug that into there. We'll switch on. Now we don't see anything. I think I can see the CRT filament in the CRT lighting. I'll just see. In fact, I'm not 100% sure I can see that. Let's see anything happens if I mess with the brightness control. Yeah. We have got a raster there, but my God is it dim. It's really, really, really dim. If I turn the control right up, I don't know if you can make that out. You can just about see a raster there. Right, we need something we can try this with. What did it? Ah, there it is. Now this gives out a NTSC composite signal, but being this is black and white, that shouldn't matter. And this is might actually be an NTSC monitor, to be fair. So let's plug this in, switch on. Now we did get, it's died away, but we did for a second then get a I don't know why it doesn't like that. See, when I first plug it in, how weird. Let me try and see if I can find a different signal source, but at least one thing we have found out is that's a green screen. If you look there. So we've got a composite green screen. Let me see if I can find something that's actually got a proper composite, a PAL composite signal, and we'll try that up and see if that makes any improvement. But we did actually see some life come out of them, but I have a horrible feeling that that CRT is horrendously worn. It's very, very, very worn. That control is right up as far as it'll go, and I can just about make out a raster on the screen. That should be quite bright. Yeah, I have a feeling that unfortunately that CRT is absolutely toast. But let me just see if I can find something else we can get a signal into this thing, and I'll be back in a sec. Okay, we're back, and I've dug out a little Atari. It's one of them Atari in a Atari joystick kind of things, little battery powered thing. But I've got that connected up, and if I switch on now, look at that. In fact, let's have a play with it. That's actually working now, and it's actually not too bad. We do still have some fairly horrendous screen burn down at the bottom there, but it does actually work. In fact, it's actually not too terrible. I mean, this has got just, you know, but it shows it does work. Let's start. There we go. You know, that's usable. Oops. You know, it is actually a usable monitor. I'm absolutely terrible at that game, and I'm trying to... Never mind. Whoop. There we go. Anyway, you get the idea, don't you? So this monitor does actually work. That's a standard, you know, PAL composite signal going into there. Obviously, it didn't like the NTSC signal from that that fake NES that I've got in that box, but that's full brightness. There's not got that much left there, but that looks fairly sharp. In fact, it looks very, very sharp. There's no blurring, there's no smearing. It looks quite tidy. There's a tiny little bit of jitter there. It could possibly do with a few capacitors replacing, a little bit of work on it. But at first I thought that CRT was absolutely shot. It had no life left in it, and well, let's just do a reset. You know, it's not bad. It's not terrible. In fact, it's quite bloody bright actually. It's really, I mean, with an Apple II, I need an Apple II or something like that connected to it. Something that would actually appreciate a monitor like this, to really get an idea of how decent it is. But I'm super pleased it's a green screen. I was expecting this to be black and white, and the other one to be what was producing the green image, but actually I am super stoked that this is actually a green screen. I'm even more stoked that the CRT actually looks fairly decent on it. I was expecting that CRT, especially seeing, I don't know if you can make it out here, but it's got something 250, sorry, something kilovolt, and then something obviously that's got a lot of been written over many times, but there is definite screen burn all the way across the bottom of the CRT there. That's a little bit of a shame, but with a nice bright image on it, actually, it doesn't really, you know, it doesn't really detract that much. You know, everything, it does work. It does what it's meant to do. In fact, some of these games look pretty damn good on a green screen, don't they? I've got to do something with it. This monitor is definitely worth going back in the console and basically just being used as a nice little test monitor for things. I mean, when I eventually get my Tandy TRS-80 Model 1, well, it's not really, it's a clone of one. When I finally get that out of hibernation, that would be ideal for, you know, using a monitor like this for testing things like that. Anyway, I'm going to leave it there for now. I hope you enjoyed having a look at these monitors, and the other monitor, as soon as I find some more information out so we can actually get a signal up it and what have you, we will be doing a video on that monitor on its own. But I'm super stoked to actually see that this one actually works fine, and I can put it back in the actual S-4000, and we can actually start looking for setting it up and getting it so we can actually use it with various different projects and what have you. Anyway, I'm going to leave it there for now. Like I said, I hope you enjoyed this little update on the project and a look at these monitors. So thanks for watching and goodbye.